Okay, so I have a hot brick removed from a, oh, sorry, this is 10.2, number 67. And I'm taking a hot brick out of a kiln. Brick, hot. Or stinky. I don't know.
One of the two.
And this is at 200 degrees centigrade.
Yeah.
Oh, that's not that hot.
Oh, above room temperature.
Above room temperature. That's still not that hot. Room temperature is like 19 degrees Celsius.
Well, you know what? It's talking.
That's pretty hot. That's pretty hot.
If I put my finger on that, I would be like, I'd be like, whoa, dude, that's hot. But if I'm like an
I mean, I set the 3D printer at this all the time. Like, you don't want to put your fingers in there, but it's not that hot.
It's hot.
Okay. Anyway, point is, after time the brick cools off, after 2 hours have elapsed, right? 2 hours?
2 hours have elapsed.
Brick.
Chilling in there for 2 hours.
Not hot anymore.
It's at 20 degrees above Celsius. 20 degrees.
20 degrees above room temperature.
20 degrees above Celsius.
Okay?
Yeah.
And then let h of t be the difference between the brick's temp and the room's temp. Assume h of t is an exponential function.
Okay.
Okay, so what does it mean if h of t is an exponential function?
There's an exponent within the function h of t.
No.
What? Oh, I was wrong.
Exponential functions have a very specific form.
Parabola.
No. A parabola is very specifically a power function.
Isn't it?
Do you guys know this distinction between power functions and exponential functions? Is that not?
Functions which exponentially grow or decline.
Yes.
I don't know. That's my only definition.
Yeah. Like
Okay, so an exponential function is a function that you can write as a e to the k t.
Wow. A k t.
Yeah.
Do you guys recognize the PERT model from biology class? No?
Yes.
Yes? Let me rephrase that. If you've had a biology class and you don't recognize this, you should evaluate in your mind whether you know anything about biology.
Whoa.
Really, you should just evaluate whether or not you remember this part and wonder what else you missed.
Yeah. Euphemistic way of saying.
Okay, so I think we have a function like this. Okay, next thing. What do I know about?
Well, you know the time elapsed and the difference, change in difference. So you can you know the rate of change. You can figure out.
You know the temperature.
Okay, I know the temperature at the beginning, right?
Yeah.
There's a T initial.
So, what is T at the beginning?
200 degrees above room temperature.
No, that's what H is.
Oh,
What's
T is
T?
0.
Okay, so I'm thinking here's a T is 0, and that goes with 200,
Yeah.
right? Because they told me that H was the difference between room temperature and the bricks.
Yeah.
Okay, so that is 1 point on my function.
Okay. 0 to 200.
What is another point on my function?
220.
I know that at time 2, we're talking about 20 degrees.
Slope.
Right? So I think I have that h of 0 should be 20. No, 200.
200.
What else should it be? They told me it was an exponential function.
It would also be 10 to the power e to the 0.
It should also be what you get when you plug 0 into this thing, right?
Yes.
So 200 should be a e to the k times 0. What's e to the k times 0? What's k times 0?
1. 0.
0, and then e to that is
0.
1.
Oh.
Numbers to 0 powers are 1 unless the number is 0, in which case you should be confused.
Right.
Okay, how about h of 2?
Well, h of 2 should be not 20.
Okay, h of 2 should be 20, and it should also be 200 e to the k times 2. You guys all see that I found the a in the first one there, so I got to use it in the second one?
Yeah. That was
Okay, next thing.
Solve for k.
Solve for k. So multiply by 1 over 200. Get 1 over 10 is e to the 2k.
Yeah. Do the natural log.
Natural log both sides. Get the natural log of a tenth is 2k.
And then divide by 2.
Multiply by a half. Get k is the natural log of 1 over 10 divided by 2.
Alright. So now we have our
Okay.
formula. H to T equals 200 E. Whoa.
So go back over here. Put in the information you just learned. So you know it's 200 e to the,
Natural log of 1/10 over 2.
and then you need that stuff, right?
That's T, right?
Good call. It should be a t, right? Because your function had a dependent variable of t.
That is sick.
Okay, so that is your function for what? What was this function doing?
For the temperature over room temperature that the brick will be at surface.
Yeah, so this takes a time t after you pulled it out of the oven and tells you how much warmer than room temperature it is. You guys all cool with that?
Yeah.
Okay, next thing.
That was our only question.
Oh, that was your only question?
That was my only question.
Okay, cool. All right, so next question is boring. C is weird. What if you had the inverse function for this?
Let's do it.
What's this thing do?
Oh, what if you had it? So it would take your heat, it would take your temperature and tell you how long it's been there.
Yeah. So this thing, right, takes a time and turns it into a temperature. Right, that's H. So H inverse, if such a thing could be found, which it can, would undo that, right? So this would take a temperature and return a time. Anybody seen a TV show where they use this
Do they turn temperature?
all the time? All the damn time.
Murder shows?
Yeah. Any crime show ever has this. Well, the coroner says they've been dead for whatever,
Oh, right.
right? Which is, and they do this,
Sick.
right?
Yeah.
So you have a method of calibrating this, which is, well, the easy method to calibrate it is you warm up like a dead person, right? Warm up a corpse and then see how long it takes to get to various temperatures.
Yeah.
That's how you kind of calibrate your model.
Yeah.
The hard way to do it is you kill a person and then take their temperature over time, but
Very
that's
dexterous.
less.
Very
Yeah.
dexterous.
Do you do it with a meat thermometer or with a?
I don't care what you use to kill them. You can kill them with whatever you want.
What if you do it with a flamethrower? I think that would change your.
Yes, it does.
Yeah.
And where they've been sitting, and there's lots of actual science that goes into calibrating this model.
Yeah, sure.
There's really lots of science, like laying on various surfaces, clothed to varying degrees with certain body fat percentages,
Right.
dismembered to certain degrees, exsanguinated versus with all your blood in you. Like, there's
I
things.
didn't know that exsanguinated was a word. That's really cool.
Exsanguinated?
Yeah, like to get rid of all your blood.
Yeah.
That's super cool.
You didn't really read enough vampire books, huh? Okay, anyway, the point is this model is useful,
Yeah.
right? Like, this thing actually gets used a lot and calibrated in kind of crazy and,
I'm gonna use
yeah,
that word in my
gross
next
ways.
Don't they,
Um,
bank, like, neutral,
Oh, this
What?
don't they use it in banks?
temperature over time.
The temperature over time function is less used in banks, but
Forget the temperature part.
But a model like this is used in banks, yes, for accumulating interest continuously.
Right, the AEK,
Yeah.
forget the T.
Yeah, there's also a similar thought that's used in annuity calculations, but it's a little different. Annuities?
Annuity.
Like your mortgage or your car payment.
Oh, I see. Cool.
Those are things called annuities.
Annuity. How do you spell that? E-N-N?
A-N
A-N-N.
stuff.
Okay. Annuity.
I have to look it up every time I teach that
A-N-U-I-T-I.
section.